Hi, good afternoon, it's Dean from the mavestar Observatory. Before we begin, we're going to have a look at the jet streams and some comparisons with magnetic field maps and temperature maps. But before we do, as usual, big thanks to those few people that have been supporting us over the last few days, and special thanks to Doug. Well done, buddy, a marvellous effort. What more can I say? So, as you can see, we're looking at the jet streams on the Earth, and we're looking at the W3 expanded map, so we don't have to rotate the globe around to have a look at different locations. We can see it all in one frame, and as you can see from what I'm seeing, guys, there is probably two distinguished jet streams, which means the polar jet streams over the northern and southern hemisphere are little to non-existent, and as a result of that, both northern and southern hemispheres around 60 degrees are pretty much covered with sub-zero temperatures, as you'll see a bit later on the map. But what is actually driving the climate and the jet streams? What's behind them? We're going to have a little look later on in this video at a couple of comparisons with, like I say, the magnetic map and the temperature map, and you just give me your feedback on whether you feel what I see is likely to be the case for that. But one thing we know about the jet streams is at the moment we're in a grand solar minimum, which means the heliosphere has shrunk, and we're also entering a magnetic reversal, or we're part in the process of a magnetic reversal, and as a result of that, more cosmic radiation is inbound, and it's ending up in our jet streams. The cosmic particles collide with upper atmospheric gases, and in turn cause cloud seeding effects, which slow down the jet stream, causes the troughs and the peaks in the jet stream to dislocate, as we're seeing over the northern hemisphere. What is left of a polar jet stream is just fragmented and is no longer part of a continuous jet stream all around the northern hemisphere. You can see that some of these troughs are over 3,000 miles in latitudinal directions, and as a result of that, it's drawing down the Arctic temperatures further towards the equatorial region, and same for over the southern hemisphere. Let's have a look at the magnetic comparison then with the temperature of today across the northern hemisphere and southern hemisphere. So on the left we've got temperature on the W3 expanded map, and on the right we've got magnetism in intensity on the W3 expanded map, and there is a pattern. You can see that if we was to overlay the northern hemisphere temperature on the magnetic map, it would show pretty much the same picture or cover the same areas. So I believe, because of what we're seeing here over the northern hemisphere, is most likely to do with the relationship of high intensity magnetism, and that seems to hold the coldest regions of the planet, and that's why we end up with pretty much the same shape over the northern hemisphere. It's not so quite distinctive though over the southern hemisphere, and for that reason I think something else is going on. But what I will say is, if we look at the right side of the highest intensity on the magnetic chart, that is going up towards Australia, you would expect to see a temperature plume in that same region. But what I will say is that on the bottom right hand side of the temperature map, if you look at it, where the purple is shows the coldest regions again, and that does play a little bit into the intensity being so high over there. It's not the case over the left hand side, around the location of Argentina. So I think magnetism does have a role to play in temperature of the Earth. The other thing is, if we look at the the Russian continent, we'll see that most of that continent is vastly covered when you compare to the left hand side of where Canada is. There's a lot more colder region over that land there than there is over the continent of Canada. But if you look at the magnetic intensity, it's weaker over Canada as well. So what we've seen here all over the last 7 years of intensity over Canada, slowly reducing down to almost 50%, and going on that rate will very likely to see, all of this intensity disappear in the next 4 to 7 years, completely over Canada. And what's happening is it's bleeding over into that Siberian high intensity region, and it seems to show us that same picture on the temperature. We can see that Canada, or at least this large area over the Canadian high intensity region is less than what it is over the Siberian region. And if that is the case, then we could see Canada get warmer over the next 4 to 7 years. That's if it's not already getting warmer right now. I know that some people are saying that Canada is experiencing lesser sub-zero temperatures and experiencing slightly warmer on average temperatures than what it used to probably 20 years ago. So maybe the reason for that is because the intensity is shrinking over Canada, bleeding over into the Siberian intensity, and as a result the Arctic climate is moving in the direction that the magnetic poles are moving on this planet. So it'd be interesting just to keep an eye on this, guys, to see how things progress in the next couple of years or so, to see if the theory is right, and it's not just the coincidence that we have over the northern hemisphere the same pattern emerging with magnetism and temperature. This is a photo of North Skull's jet streams about 9 months ago. So what you're seeing with the 2 jet streams taking precedent over the 4 that should be there is not new. In fact, it's probably been like this now for a couple of years. It seems to be the standard now for our jet streams to just have one over the northern hemisphere and one over the southern hemisphere. But it wasn't always the case like this, guys. We should have over the subtropic regions of our planet at 30 degrees a jet stream both north and southerly, and the same for 60 degrees. We should have our polar jet streams, and what we've got is a mixture of the two. It just makes me wonder if this is something that's going to set up the circumstances for another glacial period to creep in. See, the problem is with us at this present time is we don't know what a glacial period is like when it starts, because we simply have no recorded data of the last glacial period that we was experiencing or just coming out of 12,000 years ago. We don't have that data. All we have is data on temperatures with regards to probably the Vostok core samples, which was taken in the Antarctic, which do indicate that temperatures do fluctuate at almost regular cycles. And we have experienced, as a result of that, many glacial periods. But if we go back into a glacial period in the next 10 years, I don't think that our technological system will stand up to those temperatures. And if that's the case, you hear these stories about us going back into the dark ages. I think very much it could be the case. First of all, food production over the northern hemisphere would virtually shut down as a result of a glacial period creeping in. It's first of all going to start from the northern hemisphere and then gradually work its way down, getting cooler and cooler. And then when we start to see the build-up of ice packs into glaciers, then we'll know and we can state quite clearly that we are in a glacial period. I was saying this the other day in a video. It all depends on where you're situated today, whether you're experiencing a glacial period or an ice age. If you was on the Arctic or the Antarctic right now, you would say that you was in a glacial period, simply because there is glacials over the northern and southern hemispheres of this planet. But if you come a bit further down, where temperatures are still on average sub-zero, you could say that you was in an ice age at that point of latitude. It all depends on the perspective of where you are with regards to what time you're in. Now, we know 12,000 years ago that the glaciers had made their way down to a latitudinal line of about 52 degrees. Central England is where there's a load of glacial tilt deposited that was dragged from glaciers from far north. And we know they come from the north because these rocks don't exist at that part of England, so we know that they was brought further north where these rocks are actually found, and we know that that was the lowest point in that glacial period at that time. So these things do occur. You know, the northern hemispheres of our planet do experience glacial periods, but the thing is that's not quite clear is how they start and what are the circumstances that set themselves up for these anomalies to take place. Well, what we're seeing right now is completely abnormal. You know, one jet stream over the northern hemisphere and one over the southern hemisphere, where there should be two over the northern hemisphere, two over the southern hemisphere. It is really a sign of great changes on our planet, and as a result, you know, nature will have an effect on our ways of life. If we do go back into a glacial period, you know, things will change on a grand scale, guys. You know, the fact that we're going through a magnetic pole reversal on this planet is a serious subject. The fact that we're experiencing, you know, a continued 33-year decrease in solar output is a concerning anomaly. And, you know, what worries me, apart from these two things that are taking place in our lives, you know, is the complacency that people have, even with the understanding of these things. And we know that the majority of people aren't aware of these two anomalies coinciding at the same time and what the effects are. You know, just today I was looking at the muon rate, which has increased by nearly 100 and something. I think we've got 610 counts per square metre per hour. That's a lot of cosmic rays, you know, colliding in the upper atmosphere to create a lot of muons here on the surface. And if you're, you know, standing in 1 square metre of space on the surface of this earth, you're having, you know, 610 of these possibly pass through your body at any given hour. And people, like I say, are just oblivious to it. You know, they worry about making the bills, the money for the bills, of keeping the roof over their head, putting food on the table, and, you know, just very complacent to what is actually, you know, unfolding before their eyes. And even if they are in the knowledge of what's happening, you know, they still go about their business as though it's nothing to worry about. A lot of people think that when the magnetic reversal takes place on this earth, the only thing that it affects is a compass needle or navigation that relies on compasses. It's a lot more than that. When the magnetosphere of this earth, you know, drastically reduces, our protection, our primary protection from cosmic rays also diminishes, which means that there will be a lot more inbound cosmic radiation, and as a result more muons, which, you know, are on the lesser wavelength than gamma radiation, and for that reason must be more harmful source of ionizing radiation. You know, it's going to first of all increase the radiation at surface level. We're also going to see more cloud vapor in the upper atmosphere, and we're also going to see more changes to the jet streams, and as a result we're going to see more dramatic weather patterns, you know, droughts, floods, snow and ice, you know, and these things are going to change the seasons, and in turn going to change, you know, the amount of food that we produce over the northern hemispheres and for anywhere else on that matter. You know, droughts can affect crops as much as floods can affect crops, and, you know, ice in turn. It seems that all these weather anomalies are against growing, you know, the food bowl for the world. And, you know, a lot of people are just oblivious to it. And, you know, we see the way they behave on Black Friday. It's like Black Friday today. And, you know, have you seen, I was just watching a few hours ago, just the behaviour of people on Black Friday, literally punching and knocking the sense out of each other just for consumables. It's incredible. Can you imagine what these people would be like if that was food and it was the last amount that was going to get to the shop? They would be killing each other. You know, I've said this many times. You've only got to look back in our recent history of the last 80 years, back to the point where Stalingrad had that blockade. Just to get an idea and an angle on how people will behave. Go and research it. You'll find that 2,000 people during that time was arrested for cannibalism, and over 100,000 people each month were dying fighting over food rations. That just shows you how human beings will behave in a point of crisis. For many of you, last week I brought to your attention for the first time, and I know that it was breaking news. I know that most of you haven't been made aware of what was unique about that story that I broke the other week, but you know, I'll just remind you guys what happened during solar cycle 24 at the peak or solar maximum was unusual when we look at the amount of cosmic radiation that is inbound. If you look 2015 at the bottom of this chart or at the top, you'll see that we were in solar maximum, and if you look at the cosmic radiation, it was still inbound. So during a point in time at solar maximum in solar cycle 24, for the first time we had no protection at all from cosmic radiation, or very little, which meant that the solar cycle itself was not strong enough to push away all of the cosmic radiation like in all the previous other solar cycles on this chart. So, you know, we're definitely in new territory now, and if solar cycle 25 doesn't start, then we know the levels of cosmic radiation will increase beyond 14% of the background radiation that we experience from cosmic rays alone. You know, this is a new anomaly that's taking place, guys. For the first time in our recorded history, we have more cosmic radiation inbound as a result of low solar output, and it could also be due to the fact that this Earth is currently going through a magnetic reversal, and at some point we might see even greater reductions in the magnetosphere as a result of that, all of which will allow more cosmic radiation in, which will affect the jet streams even more. And also, cosmic rays, as you know, are cancer causing, and they also affect cardiac arrhythm, and that is across the range on all the biodiversity on this planet at the moment. For just over a little 2 years now, we've recorded every 3 seconds the progression of the magnetic North Pole migrating across the northern hemisphere. That's a significant resolution every 3 seconds, day and night, every day of the year. And I think it's the largest public gathering of data on this anomaly. And we've also, for the last 9 or 10 months now, been doing that also with the magnetosphere. So we've got a lot of data, and I believe, you know, we're probably 4 to 7 years away from a completed, or, you know, starting the process of that reversal. That's when, you know, the magnetic North Pole leaves its strong field lines, which holds it in a position where it migrates very slowly, and enters the weak field lines where it, you know, picks up a considerable speed and goes through its reversal process. And it's not saying that it will go for a reversal, you know, and that will be it. You know, it's not saying that we're going to go for a reversal in the space of a couple of weeks and, you know, everything will be back to normal. Because if we've experienced for the last 30 years the weather being knocked about on this planet, then if we reach equilibrium at the point where the poles reverse, we surely should have another 30 years on top of that before things start to subside a little. That is, you know, if everything plays out well. But judging on what we've observed so far with the change in weather and the low solar output combined, you know, it could be that very thing that sets up the scenario for this planet to go back into a glacial period as a result of that. And what we're seeing right now with these two jet streams could be the beginnings of that glacial period starting, because everything north above these jet streams is very, very cold, and it is the fact that the jet stream is so low that is pulling them Arctic temperatures along with it, and that's why America is experiencing those sub-zero temperatures at the levels that they are, that are breaking all records. It could continue. That's what I'm saying, if the jet streams hold their positions. Now, we know that the jet streams have been, you know, there's been 2 major jet streams as opposed to 4 what there should be, but, you know, if it continues, then it's certainly looking like it's trending to gear up for possibly another glacial period. So guys, I'm going to leave it here. You know, we are at the last day of the month before, you know, we've got one more day, haven't we? Let's see if we can raise some funds for the observatory and continue doing what we're doing, and let's see if we can beat last month's at least. And you know, just a big thanks for all those people that support us doing what we do here, and we'll catch up with you in the week some point. So, you know, guys, you know, enjoy your Black Friday, but, you know, at the same time, don't be complacent about all the other anomalies that are taking place, because for sure they're going to be at our doorstep before not too long. And when that happens, you know, we've got a lot of things to face. So I'll say what I usually do. The links are down there if you want to support, and as always, bye for now.